This example will show you how to use the DSTWU model in ASPEN Plus to simulate shortcut distillation design. The task is to perform a shortcut distillation calculation by using IK-swap property method and English units to investigate the minimum refractory ratio, minimum number of stages, and actual number of stages with specified actual refractory ratio of 5. The methods are based on the relative volatility of the chemicals and the identification of two components to be separate. In this problem, we want 99% of propane to go out the top stream and 1% of butane to go out the bottom stream. The distillation column is operated at 138 psi and 75 degrees Fahrenheit. The components to be separate are shown in the table. The first thing we need to do is to specify the split we would like. Here, we need a concept of a light key and heavy key. Light the chemicals up in order of their boiling points from low to high. The light key is the component with the lowest boiling point. In this case is propane. And the heavy key is the component that we want to separate from the light key, which is ibutane. The distillation column is then based on those two components, and the other components are split according to thermodynamics. We will use the IK-swap property method and English units for this problem. So, let's return to ASPEN Plus. With a new simulation, go to Setup and set the unit of measurement to English unit, then click Next. In the component specification form, enter propane, ibutane, and butane, and ipentane, which has a component name as 2-methylbutane. And also n-pentane. Rename it as ipentane. This is n-pentane. Then click Next. In the method specification form, select IK-swap. Then click Next. And Next again. Then go to the simulation environment. In the main flowsheet window, go to Model Palette. Select the column category and select the DSTWU. DSTWU. Add a feed stream. Distillate steam. And bottom stream. Click Next. In the feed stream, enter the operating conditions. The temperature is 75 degrees Fahrenheit and pressure is 138 psi. Add the mole flow for each component. 100 for propane, 300 for iButane, 500 for N-butane, 400 for N-pentane, and 500 for N-pentane. Click Next. It will bring you to the input specification sheet of the DSTWU block. In the column specification field, you can specify one of two specifications, namely number of stages and defect ratio. In this case, enter the defect ratio as 5 and enter the pressure for both condenser and reboiler as 138 psi. In the key component recoveries field, for the light key, choose propane and add the recof as 0.99. For the heavy key, select iButane and the recof as 0.01. Then click Next. Click OK to run the simulation. The results are now available, so let's go to the block, the DSTWU folder, and result form. In the summary sheet, you will see the calculated column parameters. You will see that the minimum reflux ratio is 2.87 and the minimum number of stages is 12.4. Also, the feed stage is at 9.7 stage. You can also try to play around by changing the value of the reflux ratio and see which parameters are affected by this change. In the stream results form, material sheet, check at the distillate stream for the mole flow of propane. The mole flow of propane is 99 pound-mole per hour, which accounts for 99% recoveries of propane in the feed, and also 3 pound-mole per hour of iButane, which accounts for 1% recoveries of iButane in the feed. We will next perform the sensitivity analysis for these distillation column parameters. I would like to see what actual number of stages will be if I vary the reflux ratio from 3 to 20. So let's go to the model analysis too. In the sensitivity folder, click New. You will create a new sensitivity case study named S1. You can rename it as you wish. In the vary sheet, this is where you need to create the manipulated variables or the variables that you want to vary. Note that only block input and process feed stream variables may be varied. In this case, we want to vary the reflux ratio, which is a block variable, So click New to create a new variable, name 1, and select type as block var, which is a block variable. Then select block as DSTWU, the variable as refract ratio or RR. In the manipulated variable limits, choose equidistance and enter the starting point at 3 and end at 20, and select increment as 1. Then click Next. In the define sheet, create variables to be tabulated or used to compute the tabulated results. In this case, we want to see the result of the actual number of stages, so click New to create new variable, name end stage. Select the category as block, and in the reference field, select type as block var. Select block as the DSTWU, the variable as actual stages. Then click Next. In the tablet sheet, click Fill Variables. Then click Next and run the simulation. Now the results are available. So go to the Model Analysis tool. Under S1, click the results. You will see the summary table plotting the refract ratio and the actual number of stages. And you also can see that the status in all rows show as OK. Try to change the lower bound of the refract ratio to 2 and the upper bound to 50 and see what happens. You can also plot the graph between refract ratio and actual number of stages by going to the Home ribbon tab. In the Plot group, choose Result Curve. Set x-axis as the DSTWU refract ratio and select End Stage as Curve to plot. Click OK. You will finally get the curve like this. You can see that as the refract ratio increases, the end stage will decrease and is reaching its minimum. And this happens also in the other way around.